Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. In this episode, we are going to be implementing animations, so we can actually have animations on the screen and Mario running around like this. Well, he's not actually running yet, but we'll add a character controller and all that good stuff in due time, okay? So let's go ahead and work on this. Before we start coding, let's take a look at some drawing and see how all this works. So the type of animation we're going to be doing, first of all, is sprite-based, right? So we're not going to be doing any bone-based animations where you could pick up an individual arm of your character and move that up and down. That's just too complicated, and I have not done that in the past, so I don't want to give a tutorial over something that I haven't done. We're just going to be doing sprites, so basically you have a sprite sheet where you have your character in multiple different phases. Maybe he's killing somebody or whatever, and then you just play through these. Maybe this one's 0.1 seconds, this one's 0.2, then this one's 0.1. So it gives you a little bit of a lag for each time the frame, and we just sort of step through each sprite. This is definitely suitable for a wide variety of cases, and it is still used in a lot of different games. So we're doing sprite-based animation, and how are we going to implement the animation? Well, we're going to use something called a state machine, which I went over in an animation episode a while back, but it's similar to the way Unity does its animations, where basically we have a bunch of different states. So say we have an idle state for the character, we have a run state for the character, and we say on the trigger run, go from idle to run, and on the trigger stop, go from run to idle. The good thing about this is, say you also have a jump state, right? Or maybe not a jump state, but let's say you have an attack state, okay? And on this attack state, you don't want to go from run to attack. If you go to attack, you need to be in idle position. So you could basically say, well, run only goes to idle. So we can only go base here. So then if we attack, then we have to go here. Then we have to go to the attack state with this trigger. This is basically just a way to keep it so that your animations don't go in an incorrect order, right? And your animation state will always be in one of these states, which is good because you'll know exactly how it's going to switch from different animations to different animations, okay? Inside of so the way we're going to code this too is basically this is just going to be an animation state class in Java. And this animation state class is going to have a list of states. Well, it's going to have a list of sprites, which basically are the different animations. And this sprite will also have a time attached to it to tell you how long to put that sprite on the screen. And then we'll have a bigger thing, which is like the run animation state with all its triggers. And we'll call that a state machine. And the state machine is basically this whole thing. It just has a list of animation states, which are each of these. And then a list of triggers. And a trigger is a string which goes from one animation state to another. Okay. And we can also, on side of each individual animation, determine whether it's looping and a few other things that I can't remember off the top of my head. Okay. So let's go ahead and implement this and see how it works in code. So like I said before, let's go ahead and simply add our animation state to our components class or components package. Now, this is not actually going to be a component, but we'll put it here because that's just sort of where it makes sense to me. Now, inside of this class, like I said, we're going to have, first of all, a string, which is the title of the animation. So like run, idle, whatever you want to call it. Then we'll have a public list of something we're going to call frames, which is just a sprite with a time. And we'll call this animation frames equals a new array list. And we'll create that object in just a minute. Then we'll have a private static sprite. Call this the default sprite equals a new sprite, which will return if none of the frames work. That way we don't actually break. It just sort of shows a pink pixel or something. I don't know. We'll figure it out. And then we're going to have private float, and let's call this time tracker. So this will basically be tracking the time that we're on a single frame and switch it from frame to frame as needed. Private, we'll have a private transient int current sprite. So this will be whichever sprite we are currently on, and we'll initialize that to 0. Let's also make time tracker transient because it really doesn't matter and we don't need to save that out. And then we'll have a private boolean does loop, which will determine whether this animation loops or not. Let's go ahead and add that frame class real quick before I forget. So let's just go in here, create a class called frame. This is very simple. It's just going to take in public sprite, and we're going to have a public float frame time, how long this should last. We'll have a default constructor. That way you can serialize, okay. And then we'll have a constructor that takes in a sprite and a time. And then we'll just say this dot sprite equals sprite, this dot time, frame time equals time. And if we go back into animation state, we should see that this is all good. Let's alt enter and import this. We're now completely good. Now, the way I like to code this, let's also add array list real quick before I forget that. The way I like to code stuff like this is I like to code the functions first to see how I'm gonna actually build it, because the best way in my mind to do this is like, I wanna see how I'm gonna use it, right? So in my mind, I thought it would be good to have something called add frame, and this takes in a sprite and it takes in a frame time. So this will add one individual frame, and then we can literally just say animation frames.add new frame, sprite, frame time. That is very simple, and it is simple to use as well, which is good. Then we'll have a public void set loop boolean does loop. So this way we can set it to loop or not. So we'll say this does loop equals does loop. And then we have an update function, right? This update function will basically switch it from frame to frame for us without us having to know about how it's working or what it's doing or anything, right? So what we'll do is we'll say if current sprite is less than animation frames dot size, which will basically make sure that we're not going to get index out of bounds error, right? We don't want to do that. We'll say time tracker minus equals dt. So we subtract the time. And we'll say if time tracker is less than or equal to 0, well, then it's time to move on to the next frame, right? So if we're on frame 0, we need to go to frame 1. If we're on frame 1, we need to go to frame 2, so on and so forth. Then we'll say if we do not have the current sprite, so whichever index is not equal to animation frames.size minus 1. So if we're not on the last frame of the animation and it doesn't loop. So if we're on any frame before the last animation and it's not looping, if this is not true, so basically this is saying if we need to move to the next frame, then move to the next frame. That's all that says. So let's say current sprite equals current sprite plus 1 mod animation frames dot size. This should work for looping animations and animations that want to stop at the end. Then we can say time tracker equals animation frames dot get current sprite, so whichever one we're on, dot frame time. And this will ensure that we loop for the appropriate times for each one, and we continue to loop through. Last thing we're going to want is a public sprite get current sprite, which will return whichever sprite we're on. We'll say if current sprite is less than animation frames dot size, then we'll just return animation frames dot get current sprite dot sprite. Otherwise, we'll just return that default sprite we initialized up there. And let's go ahead and make this default sprite something a little bit more flashy so that we actually know what this is. So we'll say public animation state, create a default constructor, and then we'll just say default sprite dot. Well, looks like we can't really do that. So, I mean, I guess you could get a custom texture and then set this to like a pink texture or something, just so that you know that there's an error and it's really obvious. This will just return a white sprite for now, which is fine with me, honestly. So this should do everything we need to do inside of animation state. Almost everything. We'll see a bug in the future, and then I'll talk about how I fixed it. Now we need our state machine, which is going to be a component, and it's going to be a little bit more complex. So we'll say create a new class, call it state machine. And the first thing I'm going to do is create a private class in here. If this was C++, I would just create a struct inside of the implementation file, but this is sort of the Java way to do that. So this is just a class that only state machine cares about, which is why I'm making a private class in here. This will take in a private string trigger. So this is the trigger, and then a public string state. And I'm actually going to move that up. Then we'll create a default constructor that does nothing. And then we'll create a constructor that takes in a string state and a string trigger. Okay. And then we'll just say this dot state equals state, this dot trigger equals trigger. This is just going to be a helper class for us. It doesn't need to be very fancy. We will need to override equals. So we'll say public boolean equals object O. And this is nothing fancy as well. We'll just say if o.getClass does not equal state trigger dot class, return false. And then we'll say state trigger t2 equals o state trigger Oh, so we'll cast it once we know that it is the same object, and then we'll just say return t2.trigger dot equals this dot trigger, and t2.state dot equals this dot state. All right. And then we also need to override our hash function because we will be putting these inside a hash map. So we'll just say public int hash code, and we'll just return objects.hash trigger state, and import objects by hitting Alt-4 or Alt-Enter. And this should say hash, not has. There we go. And then that should hash it for us, and we don't really have to worry about that anymore. Next, we'll say, what do we need inside of this state machine? We basically need a list of triggers, right? So we'll create a hash map, which takes a state trigger, and it returns a string. So it'll be like, basically, you have a trigger, and on that trigger, I want to go to this state, right? So when you're on this state and you hit this trigger, go to the state that this title says. And we'll just call this state transfers equals a new hash map. We're also going to have a private list of animation state, which is going to be our states, and I'll just make that a new array list. And then we're going to have a private transient animation state, which is the current state, and we'll initialize that to be null. And we'll have a private string, the default state title, which we'll initialize to empty string. So basically, this is the default state that we want to end up in, animation state. And then this is the current state that we are in, which is null because we don't have one yet. So once again, I like to code to implementation. And the way I would do this is I would say public void add state animation state. And this can literally just say this dot states dot add state. Okay, so we add a new animation state. That's simple, nothing too fancy there. What if we want to add a state transfer though? Trigger, transfer, whatever, you know what I mean. So we can say void add state trigger. This takes in a string from string to string on trigger. Okay, so this will basically say go from this state to that state on this trigger. And this is simple too. We can just say this dot state transfers dot put a new state trigger from to, or I'm sorry, from, and this is on trigger, and then to. So we put in our hash map. This is the trigger. So it goes from this state on this trigger to, and then we just give it whatever the state title is. So we get a state trigger, and then it returns the state we need to go to next. Lots of states, I know. Using this, we can actually build up our trigger function, right? So we can say void trigger string trigger. So you can call this function, which will trigger the next animation, whatever trigger your is. So we can say for each state trigger that we have inside of our state transfers key set, we can say if the state's state, so the state's title equals the current state's title, and the state's trigger equals dot equals the trigger that was passed in. This basically means we are on the state and it has a trigger equal to the trigger they passed in. So we know where we need to go. We can say if state transfers dot get state does not equal null, then we'll say int new state index, and they can add in a null transfer, which basically means it goes nowhere. Then we'll say new index equals states dot index of state transfers dot get state. And I'm just realizing that this isn't actually gonna work quite the way we want it to. So we'll say int new state index equals -1. Then what we're gonna do is we're gonna say for int, or we'll say for state animation state s in states. Okay, we're getting wild here. We'll say if s dot title dot equals state transfers dot get state. So basically, if we have the animation that this needs to transfer to, then we'll say new state index equals index. And we'll just say int index equals 0 right there. And then we'll just do an index ++ here. And then we'll just break out of this loop, which means we should be good. Then we can say if new state index is greater than -1, current state equals states dot get new state index. All right, so this is a little bit complicated and convoluted, but it will basically just transfer us to the correct state depending on the trigger. If it has it, and it will do nothing if it doesn't. And if we get through this loop and we don't find one, we should say system.out.println unable to find trigger plus trigger. And that way we know something went wrong and we don't blindly go on. And we'll just return if we find something. So we can return out of this guy right here, which should be good. And I think that is, if we click onto this bracket, that's this bracket right here. So we can return right here. And that should do everything we want it to do. Okay, and then I'm gonna go ahead and override our start method since this is a component. I believe it's a component. We did not extend component, which we should. So we'll say this extends component. Should be good. And then right in here, we'll just say for animation state in states, if state.title.equals default state title, then we'll say current state equals state break. So every time we start the scene, we'll switch to the default state, which is good. Then we'll say at override public void update float dt. And inside of here, we can say if current state is not null. Then we want to update it. And then we also want to make sure that we set the sprite to the appropriate sprite that we need, right? So we'll just say sprite equals GameObject.getComponent sprite render.class. If sprite's not null, then we'll say sprite.setSprite current state.get current sprite. Cool, autocomplete did that for me. And then we'll go ahead and copy this, paste it, editor, update down here, just so that we get this updating in the editor. And when we play the scene, if you don't want it to update while you just have the editor running, you could just remove this loop and that should be fine. Okay, last thing we need to do is just make an IamGUI function. That way we can actually modify this code. So we'll say for animation state in states, we'll just say IamString title. So you can change the title if you want. New IamString state.title. Let's go ahead and import that as well. And then we'll say IamGUI.inputText state, and then we'll do a colon and we'll just say state.title. Then we'll say state.title equals title.get, right? So we just have a text box there that says title, and then we'll say index equals 0 because we're about to loop through a few different things. And let's actually set index to 0 up here, which should be a little bit better. That way we give things a unique ID. We'll say for frame inside of state.animationFrames. We want to list each of the numbers so that they can change them if they want. So we'll say float temp equals new float 1. Temp 0 equals frame.frameTime. IamGUI.drag float. We'll call this frame plus index so that they know which frame this corresponds to. And then we'll just do a time so that they know this is the frame time. Then we'll give it temp and we'll say 0.01f, which was good for me. Change this to title too. Shouldn't be state.title, it should just be title. Then we'll say frame.frameTime equals temp 0. And we can say index plus plus. Okay, that should be good for that. And then lastly, we'll put a checkbox up here too to check off whether it loops or not. So we'll say IamGUI.checkbox does loop. And then we'll do a space there just in case. And then we'll say state.doesLoop. Or we'll actually just make an IamBoolean. And we'll say does loop equals state.doesLoop. We'll make that public too, just so that we can see that in a second. And then we'll import that. Then we'll just say does loop. And then we'll just say state.setLoop does loop, which should be good. And we just want to make sure that we get that value. Okay, there we go. And then let's go ahead and make this public just so that we can access that, because I really don't care about private public things that much anymore. So that should be good. We just need to make sure we do no IamBoolean. And now we have an IamGUI function that should let us alter different things. Now we need a way to get animations into the scene. Well, If you look at the GitHub repository linked in the description, you can find all these sprites and images there. And I have 2 sprite sheets, one cleverly called sprite sheet and another one cleverly called items. Okay, very descriptive. Those are sprite sheets that we will be using. And I am going to go ahead and go into level editor scenes so that we can actually start adding some things, right? So first of all, what I want to do is I basically want to have a bunch of different tabs down here in this bottom window. So we have like this, and then we have prefabs, whatever else we want. So let's call this blocks instead of window, and then we'll say if I'm GUI.begin tab bar, and we'll just call this window tab bar. Wrap everything in here in that tab bar. Then we'll say if I'm GUI.begin tab item, and we'll call this blocks as well. Then we'll just wrap everything in that. So if we're on the blocks tab, we'll just leave this sort of the default. And then we'll make sure to I'm GUI.end tab item here. And also I'm GUI.end tab bar here. And then we'll say if I'm GUI.begin tab item, call this prefabs. Actually, let's call this, yeah, we'll call this prefabs. Okay. So this will sort of be like special objects that we create specifically for this. And then I'm going to do I'm GUI.end tab item right there. We'll put nothing in there for now just to make sure this is all working right. And then right here, I'm just going to call this objects instead of blocks because that's a little bit more descriptive. First of all, it's going to mess up everything for me right now. So I'm going to do that, fixed up. Then I'm going to dock this back into here. All right, everything looks better again, except now we have some tabs. So we have blocks and we have prefabs, which is cool. So I'll exit out of that. Now inside of the prefabs bar, we basically just want to add some items very similarly to the way we did right here. So I'm going to copy that, paste it right here. Instead of getting this from sprites, I'm going to say sprite sheet player sprites equals asset pool dot get sprite sheet. And we'll call this assets/images/sprite sheet.png. Very clever name, right? And that should be the player sprites. Then we'll say instead of this is being sprites, we'll do this. This is player sprites.get sprite 0. Okay. We won't push any IDs because we shouldn't have to worry about that. So we should be good just doing this all as is. And then last thing I'm going to do is I'm going to change this to generate Mario, and we will create a function that does just that in just a minute. And everything else should be fine. Okay. And then I'm just going to do an I'm GUI dot same line right there. Cool. So let's go into our prefabs and create a function, call this generate Mario. Let's copy this one as a reference, rename it to generate Mario, and remove all of that. Going to go back into level editor scene initializer. We will need the sprite sheet in here as well. So let's go get that again. Go back into prefabs. And then I'm going to go ahead, just paste that sprite sheet right there so that we have that available. Then we're going to call this Mario because this is what this will be. And we'll call that Mario up there too, just so that we know. And actually, let's call this, instead of creating the game object and everything like this, let's use the function we have right here. We'll say this is equal to generate sprite object. We'll give it player sprites dot get sprite 0, and then we'll give it a size of 0.25, 0.25, which should give us a base object to work with. Let's make sure to return Mario here. And now we want to add an animation machine to this, right? So we'll code all this in. We'll say animation state run. So this is going to be our run state is a new animation state. And then I'm going to say run.title equals run. And then we'll say the default frame time is 0.23f, which is something that I thought looked okay. And then we'll add all the different frames. You could create a bulk add frame method if you want to, but it's easier this way since we do have to add frames individually. They're not really in line. So I'm going to get this first sprite that we have inside that sprite sheet. Then I'm going to get sprite number 2, which is at index 2, then 3, then 2, so it should just sort of loop back and forth. And then we'll set the looping to true so that this does loop. Then we'll create a state machine. We'll call this state machine equals a new state machine. And we can say state machine.add state run. So now we have the run state available to us in the state machine. We'll say state machine.set default state, which I'm not finding. So let's go into state machine real quick. I know we coded that. Oh, maybe we didn't. So we also want a way to set the default state, right? So let's go ahead and we'll say public void set default state, string animation title. And we'll say for animation state in states, if state.title.equals animation title, then default state title equals state. And then we'll just say if current state equals null. Then we'll say current state equals this state that we just hit, and then we'll break out of this. We can actually just return out of this. Otherwise, if we can't find one, we'll say system.out.println unable to set default state, or we'll say unable to find state plus animation title and set default state as a little note to ourselves. And this should be set to the animation title. There we go. All good. Let's go back into prefabs now. And now we can set default state to run, which is just run.title. And that should work for us. Now we will add this new state machine to Mario. So we'll say Mario.add component state machine, and he should have that. So if we hit Shift F10 and we hit prefabs, we get an error. Nice. So let's see what's going on here. Asset pool. We never added the sprite sheet, of course. Let's go into level editor, scene initializer real quickly. Scroll up to here. I am going to copy this guy right here because it is very similar to what we need. Paste it right here. Change this from sprite sheets to images / sprite sheet. We do the same thing right here. Change that to sprite sheet so it has the correct path. And everything is the same except this guy just has 26 sprites. Let's go ahead and copy this one more time for now because we did add 2. The second one is called items, and we'll just call this items. And this one is almost the same except it has 43 sprites in there. Okay, now if we hit Shift F10, we should be good. Fingers crossed. It's running. If we hit prefabs, we get Mario here. And if we drag Mario in, you can see he's running. So then if we were to drop him, he's not showing up. But if we hit play, stop, he's still not showing up. He's there, he's just invisible. So what's going on there? Well, we basically have to make sure to refresh the texture ID because the texture ID sort of gets lost in translation as we're copying things and stuff. And in order to get around that, we can go into our animation state, or actually let's go into our state machine and we'll create a function up here that we'll just call public void refresh textures, which will basically just make sure that we actually have our textures showing. So we'll say for animation state in states, state.refresh textures. Then let's go into animation state and add that right here. So we'll just say public void refresh textures. And we'll say for frame in frames, frame.sprite.set texture, asset pool .get texture, frame.sprite.get texture, .get file path. Okay, so it's kind of convoluted, but we're basically, and I called this animation frames, not frames. We're basically just making sure to reset that texture ID reference so that it actually has a handle on that. And now if we go ahead, first of all, when we're loading the scene, it's not working. So let's go ahead and fix that first while it's fresh in my mind. So if we go back into level editor, scene initializer, right here, we sort of did something similar for sprite renders, and we'll just add in another one for animation or state machines. And we'll just make sure this is state machine, call it state machine. And we will simply say state machine dot refresh. So if we run this one more time, then we should see, we get Mario, cool. And he's running around. If we click him and click state machine up here, we can turn off looping. So if we turn off looping, you'll notice he stops at the last frame. That's because he'll run through the animation once, then stop. And then if we turn it back on, he'll continue through frames. If we change one of these variables, it changes that individual frames time and everything. And this all just sort of works. So you can actually sort of start building a level, right? If we do this, then we've got a lot of different objects in the scene. And then if we go ahead and add Mario back over here, well, that's not working. So what's going on there? Well, if we press play, then stop, it works, but it's not finishing. And that's because if we go into mouse controls, we basically just need to make sure that we refresh it as we're placing objects here. So we'll just say if new object dot get component state machine dot class does not equal null. Then we'll say new object dot get component state machine dot class dot refresh. Okay, so that way as we place it in the scene, it should get the textures refreshed and everything. So we can sort of start building a level now, and it's already turning into something cool. We don't have a question block in here, but I have the sprites and everything there. What I would suggest you do if you want to add the question block, go into our prefabs class, create another function like this. I'm actually going to copy this. Maybe we will do it real quick. So we just go into here, we'll say generate question block. This will take in the item sprite sheet, and we'll just call this question or flicker animation. This is like the flicker animation, right? And this one is actually going to take 0, 1, 2. And I'm going to change this frame time to 0.57f. We also want this to loop. And yeah, that should be fine. We can change this to like items just so that it's technically correct. The variable names don't really matter. It's still going to work the same. And then we can change this to question block, since that is what this is, just that if we're rereading code later, we won't get confused. Okay, so that should do the question block. And then if we go back into level editor scene initializer, we can go down here, add another button to our IMGUI window. Actually, we should copy all of this because we will need to change a few things. So we'll say items equals all this stuff, and then items.png. And then we'll say sprite, remove that so that we don't declare it twice. We can leave all that stuff the same. And then just remove that so we don't set that twice. Remove that so we don't set that twice. And I think that should be good. So now we should be able to add question blocks too. So if we run this again, we got Mario. That's the wrong image. So, oh, we're still using the player sprite. So if we just change this to items, there we go. And then if we change this to generate question block instead of Mario, we should be good. So if we go ahead and redo this and then hit prefabs, we get question block in here. And now we have a flickering question block. So we can add question blocks, Mario, they're all animated. It all worked great. One last thing I will mention very quickly. Notice this little glitch here. We see the gizmos. That is what that is. That's the gizmos, and we don't want them showing up when we're not playing. So just go into Gizmo real quick. Gizmos, or Gizmo system. Maybe not Gizmo system, but if we go into Gizmo itself right here, then in the update method, we can say if x-axis object, or actually, let's just make this simple. We'll say x-axis object.get component sprite render dot class dot set color dot set color to new vector 4f 0, 0, 0, 0. Copy that, duplicate it for the y-axis object. Copy both those lines. Actually, I don't think we have to copy those lines. I think that should be it. And then if we click on objects, they still show up. If we click off the objects, but then if we hit play, you don't get that weird glitch over there anymore. Okay, so that is it for this tutorial. I hope you guys enjoyed it. I hope you guys learned something. We now have animations inside of our game engine. Next episode, we'll go over adding sound, and then hopefully we'll start coding Mario and get the rest of this complete. So I look forward to doing those, and I'll see you guys there. Thanks.